Welcome to your Chapter 14 Part 1 video on environmental health and toxicology. In this particular section of study, we are going to be covering chemicals and their effect on human and also animal health. Alright, so estrogen mimics. To back up, to explain the way that some chemicals affect the body is that they mimic chemicals that are already in your system, which chemistry is just nothing but the way that molecules are shaped. And if they are the right key to fit into a lock in your body, they can affect a change. So if they have similar shapes to something that already exists in your body, they can affect what goes on there. One of the things we're going to keep coming back to is that there are a lot of chemicals that are called estrogen mimics. They have a very similar shape to estrogen and they influence the body in the same way that estrogen does, and this is true of both males and females. DDT is an estrogen mimic, and then atrazine, which you can see here, it is not an estrogen mimic, but what it does is it converts testosterone into estrogen. And there is a study in your textbook that covers Lake Apopka, which is actually very close to where I grew up, and a study that was done there, I think in the 80s, where they started noticing that all of the alligators were being born female, and it turns out that atrazine, which is an herbicide, was washing into these lakes and influencing the gender of the reptiles, causing them to all be born female. Now in people, it doesn't mean that males who ingest things like atrazine or DDT are going to become female. We will discuss the indirect effects that estrogen mimics have on people. The next question that you have is identify various what component of fertilizer runoff may act as an endocrine disruptor? Nitrate. Now, you don't know what an endocrine disruptor is quite yet. We're going to talk about it a little bit more in this section, but just to kind of define it for you, your endocrine system is the one that controls hormones, which is everything from pleasure hormones to things like testosterone and estrogen, human growth hormone, weight regulation. So anything that is an endocrine disruptor messes with that system in your body. Alright, identify various physical, chemical, biological, and cultural hazards and explain their impact on human and environmental health. Physical ones occur naturally. It's everything from earthquakes to volcanic eruptions, fires, floods, blizzards, landscape slides, hurricanes, droughts, exposure to UV light. Those things can kill you on the spot. They can cause injury. They can obliterate your food and water supply, which does kill you a little bit later on. Chemical hazards that we deal with are either man-made, things like disinfectants and pesticides. We're going to be talking about both of those a little bit more. And then natural ones like snake venom. Biological hazards are everything from viruses to bacterial infections to pathogens like the one that causes malaria, and then parasites like tapeworms. And then there are cultural ones. These vary obviously from place to place. So everything from smoking to drug use to nutritional choices to crime and driving. Being hit by a car is not an issue in places in sub-Saharan Africa because nobody's going to have a car in the first place. So it is not a hazard in that particular land. Alright, how are infectious diseases different from nutritional diseases? Covered in Unit 4. Be familiar with common infectious diseases. Infectious diseases are transmissible where nutritional ones are not. Some examples are, and here are the big four that you can remember: malaria, cholera, tuberculosis, and influenza. Obviously HIV is another one, but you really want to remember one of each type. Remember a virus one like influenza or HIV. Remember one that's caused by a protist, that's malaria, and remember it has to be transmitted by a mosquito. Then you have tuberculosis, which is bacterial in nature, as is cholera. Tuberculosis is transmitted by coughs. Cholera is transmitted by contaminated water. It accounts for 26% of deaths worldwide, and as you can see here, tropical diseases are expanding their reach. Why? Because a lot of them are transmitted by vectors like insects. Alright, so let's see what else we've got on here. What two factors largely determine why humans develop killer diseases like heart disease and cancer? Genetics and environmental factors. Okay, a little bit more on malaria Again, you do need to know what's going on here. The symptoms, I don't know that you'll actually be asked about these types of things. Definitely know that any disease that we talk about, you have a greater susceptibility to other diseases that can end up killing you. Again, malaria has been on the rise, especially in places where people are already afflicted by HIV/AIDS. And here's a distribution of malaria. This is getting wider as it gets warmer, and the areas you can find the the type of mosquito that carries it, its range increases. So that is a side effect of climate change. And this is interesting in that these $5 nets can actually protect you from the mosquitoes that carry malaria. All right, so again, here are the two things your book lists that determine why you get heart disease and cancer are your genetics and environmental factors. You're not going to get skin cancer if you don't ever come out in the sunlight. But as we're beginning to find out, and I'll address this in class, viruses we're starting to find out do cause some sorts of types of cancer, and they may also be, at least in part, responsible for heart disease. What percent of worldwide deaths come from infectious disease? Again, that's 26.1, basically 1 out of every 4 deaths. How does some infectious diseases spread from person to person without direct transmission? That's through a vector, like mosquitoes spread malaria, ticks spread Lyme disease, fleas spread the bubonic plague. Other mammals will spread rabies amongst in between species. All right. What is the main use for DDT in developing countries? It's to kill mosquitoes that transmit malaria. As we're going to find out, DDT is not a good thing, but when you have a choice between malaria and the possible buildup of DDT in your system, you're probably going to go ahead and use the DDT anyway. Let's see. I feel like I've skipped something. I apologize for that. Yes, I did. I skipped a lot of things. Backing up. Why do infectious diseases widely impact populations in developing countries but do not have the same impact in developed nations? Say differences in hygiene conditions and access to medicine. It's tightly correlated with wealth, as you can see right there. And this is a link that we will explore when we are in class. All right, so again, when you poop where you drink and you don't have access to medications, disease is going to spread. Plus, the hottest places are the places where you have the most insects that spread disease, so that is an issue. What one factor is responsible for localized diseases spreading quickly to other countries and continents? It's global mobility. Ever since we became a global population where people get on planes all the time and go from one place to the other, that means that diseases that stayed in one place then spread everywhere. Give at least 2 other reasons why some human diseases are spreading beyond their historic boundaries. Antibiotic resistance, again, climate change, more areas for disease to survive in, and then habitat alteration. All right, let's see. Do you realize some of the impacts of disease? You have everything from you die, developmental issues in children, diminished productivity, loss of fertility. There are some types of diseases that when you catch them, it renders you sterile. And then also your social standing is also an issue. Definitely depend on the supplemental lecture for more detail on this stuff. And here are just some ways that toxic chemicals can move through the environment. We are going to be talking about this stuff. And again, back to the questions I had skipped ahead to. What is the main use for DDT in developing countries? Kill mosquitoes that transmit malaria. Definitely make a list for yourself as to, and I think maybe I'll make a list to put with your lists in terms of disease. List 1 bacterial, 1 viral, 1 protist causing disease. Bacterial, cholera and tuberculosis, and viral, influenza, West Nile virus, and HIV when it becomes AIDS. And then the protist is malaria. All right, something else that can affect humans is something called radon. Radon is a highly toxic radioactive gas that is colorless and undetectable without specialized kits. It seeps up from the ground in areas with certain types of bedrock. It can build up inside basements and homes with poor air circulation. it can lead to lung cancer. As a matter of fact, it is the second leading cause of lung cancer in the United States. Clearly, this is not as much of a risk here in Florida because we don't have basements. But uranium occurs naturally in the soil everywhere, and when it breaks down and there are cracks in the foundation, it can end up in your house. All right, lead is something that's been used a lot up until recently. It was used to brighten color, so it was used in everything from face foundation to lipsticks and in paints for toys until 1978. And considering that you can absorb this stuff through your skin, and then also think about what kids do with their toys, you can understand how this ends up in people's systems. And as with all diseases and toxicants, the younger and the person is, the more it affects them, and the longer term the effects are. If you have a kid who ingests lead when they're young, it can either kill them or they can be left with permanent developmental delays, like in terms of developing the ability to do things that you take for granted. There's still lead-based paint in 24 million U.S. homes because, again, lead was used to brighten colors in paints we applied on the interior of a house, up until 1978. You also see it in pipes for water, bullets, which can poison wildlife, stained glass, foreign toys, and candy. I highly encourage you to not purchase anything from a dollar store that you eat that you cannot 100% identify as being manufactured in the United States. Also, kids' toys I wouldn't buy from a dollar store either. Next thing that, all right, let me go back to lead poisoning. My apologies. What are the effects? Damage to brain, liver, kidney, and stomach, learning problems and behavior abnormalities, anemia, hearing loss, and death. It can come from drinking water that's passed through lead pipes, and then paint made before 1978. Kids love to put stuff in their mouth, and they will eat paint chips. All right, what is asbestos and what is it used for? It's a mineral that forms long, thin, microscopic fibers. It's used for insulation, sound muffling, fire resistance, and building insulation and other products. Exposure to it can lead to lung scarring, lowered lung function. Due to the scarring, it's called asbestosis, and it can also cause lung cancer. And it's only recently we figured out this stuff was bad, so you can also imagine getting it out of a building is as lethal, potentially lethal as it was to actually install it. So you have to get it out very, very carefully, because even the dust that occurs when you pull it out is problematic. All right, what are PBDEs? They're polybrominated diphenyl ethers. On the exam, just recognize that B is bromine, and you'll be in good shape. It has fire retardant properties. You find it in computers, televisions, plastics, and furniture. This is the stuff that is most often found in children's fire-resistant clothing. A lot of children's pajamas are marketed as being fire retardant and has this stuff on it, and it bioaccumulates within someone and then it biomagnifies up the food chain. It's persistent, which means it doesn't break down, and it appears to be an endocrine disruptor that affects thyroid hormones. It may affect brain and nervous system development and may cause cancer. You're also going to notice as we go through this that I'm going to be saying a lot of mays and mites, because there's just not a lot of stuff that's out there on this in terms of long-term effects. And then please be aware about how toxicity, dose, and length of exposure plays into a toxicant's effect. Please remember this: the dose makes the poison. Gallons of one toxicant may be less toxic than a drop of another toxicant. Some things are effective right away in terms of how they impact you. Others may take time to build up and make an impact. And anything is toxic in the right amounts. Now, what if that's, so that's dose. That's a huge thing. Also, your age, your gender, and your current health, your genetic makeup. How sensitive are you to something? If you're allergic to certain things that your friends are not, you really understand this. How well does your body's detoxification system work? How is your liver in good shape? Solubility. If something is water soluble, it's going to pass out of your body faster than if it's fat soluble, which is why if you try and load up on vitamin C in an effort to keep from getting a cold, it really doesn't work, because your body will excrete it out once it gets as much as it needs for that particular length of time. And then also persistent. We always come back to this for the really, really bad toxicants that can really hurt animals and people. If it doesn't break down, it's basically like a little sharp object just laying around waiting to cut someone. And then biomagnification. This goes along with the fat soluble. If something is fat soluble, it's going to be stored in fatty tissues of little guys that get eaten by big guys, and something that is like a negligible concentration in little dudes, when it's spilled out in the environment, becomes a huge issue when it makes its way up the food chain. And then there are two types of responses you really need to know about: acute and chronic. This is, some things are effective right away. Acute effects are things like a peanut allergy where your throat closes up and you die. Chronic effects are things like getting lung cancer after smoking for 20 years. And this right here should tell you why it is so difficult for us to figure out exactly what it is that's affecting a person, because it is impossible to isolate a toxin's effect on a person based on what levels they're getting it in, because they're getting all sorts of other things. Are these things amplifying the effects? Are they deadening the effects? What's going on here? We don't know. All right, and that is the end of this particular section.